Welcome to This Explainer. Today, we're unpacking a massive breakthrough from Google DeepMind that's literally shifting the foundations of math and tech. We're talking about AlphaProof Nexus, and let me tell you, it just pulled off something that has the global mathematical community absolutely stunned.
So let's kick things off with a question. Imagine a puzzle so mind-bendingly complex that the absolute brightest human minds couldn't crack it for over half a century. We're talking about the legendary open problems posed by Erdős. Some of these have sat completely unsolved since 1970. Mathematicians have spent their entire careers just chipping away at them. It's kind of like trying to solve a Rubik's Cube, but with a million sides.
But what if I told you an AI just swooped in and solved it overnight? And get this, the computing cost was only about a few $100s. No way, right? It literally solved a half-century-old mathematical mystery for the price of a decent hotel room. And it didn't just guess, it provided a mathematically flawless, machine-verified proof. This isn't just a win for abstract math, guys. It's a massive, blinking neon sign that the economics of solving impossible logical problems have permanently changed. Which brings us to our first section, the 56-year math mystery. Okay, let's look at exactly what DeepMind's AlphaProof Nexus actually did. The system managed to crack 9 of those open Erdős problems. That includes heavyweights like Erdős number 12 and number 125, which had totally stumped human mathematicians since 1970 and 1996. Problem 125, for example, involves these incredibly complex calculations around base 3 and base 4 numbers, but the AI, it just systematically tore it down and proved the answer with absolute 100% certainty.
And to really put the scale of this achievement into perspective, it spans way more than just one discipline. It attempted 353 open Erdős problems, solving 9 fully. But wait, there's more. It also proved 44 open conjectures from the online Encyclopedia of integer sequences, resolved a 15-year-old mystery in algebraic geometry, and, get this, discovered a completely novel algorithmic parameter in convex optimization. So it didn't just verify existing math, it actually invented a better mathematical parameter than humans had ever found. Absolutely wild.
Moving on to Section 2, Student Meets Strict Teacher.
All right, let's address the elephant in the room. AI hallucinates, right? They make things up all the time. So how on earth did a system do this without just hallucinating a bunch of fake math? Well, think of it like a brilliant but maybe a little sloppy student meeting an ultra-strict teacher. On one side, you've got the student, the Gemini 3.1 Pro language model. It's highly creative, throws out great mathematical intuition, but yeah, it's prone to logical hallucinations. On the other side, you've got the strict teacher, the lean compiler. Lean is a formal proof checker. It has zero creativity, but it demands absolute 100% logical perfection. If a proof causes lean, it is mathematically guaranteed to be true.
This whole dynamic creates what the researchers call an agentic loop. Basically, the AI analyzes the problem and tosses out a draft proof. It sends that draft straight to the lean compiler. The compiler then mechanically verifies every single logical step. If it finds a flaw, even the tiniest little syntax error, it fails and kicks a specific error message right back to the AI. The AI reads the feedback, tweaks its draft, and tries again. And this loop just repeats, sometimes thousands of times, until that ultra-strict teacher finally gives it a perfect score. The secret sauce making this whole thing tick is formal verification. That's the process of mechanically proving that software or logical statements behave exactly as intended. Because lean checks every step so rigidly, there's literally no room for the AI to fake a result. It's like an automatic hallucination filter. Actually, when researchers looked at the AI's failed attempts, they saw it trying to hallucinate helper lemmas all the time, but lean caught them immediately and just flat out rejected them.
Okay, on to Section 3, the plot twist. Keep it simple. So DeepMind initially built this super complex, highly engineered version of this system called Agent D. We're talking evolutionary algorithms, LO ratings for proof sketches, reinforcement learning tree searches, the whole shebang. But here's the plot twist. The absolute simplest version of their system, Agent A, also managed to solve all 9 problems. Agent A didn't use any of that fancy evolutionary stuff. It was literally just a basic language model bouncing drafts back and forth with the lean compiler.
If you look at the data here, it's pretty incredible. While the tricked-out Agent D was definitely cheaper and faster to run on the absolute hardest problems, like Erdős 125, the simple Agent A entirely matched its raw solving capability, as long as it had enough time. But, and this is crucial, if you take away the lean compiler or if you try to use smaller models, the solve rate drops to exactly 0.
So the magic is strictly in that pairing of a smart AI with strict compiler feedback. This quote from the DeepMind researchers hits the nail right on the head. They're seeing an ongoing shift away from hyper-specialized systems towards simple agentic loops as these models become more capable out of the box. The grounding that the compiler provides is really all you need to unlock the AI's reasoning power. Which leads us into Section 4, Zero Hallucinations Guaranteed. Now, you might be wondering, why does this matter for the rest of us who don't spend our weekends pondering 56-year-old integer conjectures? Well, it matters because this system proves we can eliminate the AI hallucination problem entirely for strictly logical tasks. I mean, the biggest hurdle in tech right now is trusting AI, right? But by forcing the AI to formally prove its work, it literally cannot lie, fake, or confidently make things up. If it's wrong, the compiler just stops at cold. As one media outlet put it so perfectly, the spark of the mathematical singularity has been ignited. But hey, this isn't just about math. Being able to generate provably correct logic, totally autonomously, that paves the way for AI to be trusted with the code that runs our hospitals, our banks, and basically all of our most critical digital infrastructure.
Let's break that down in Section 5, what this means for you.
Let's look at exactly how this bridge from abstract math to everyday life is going to impact you personally. Think about the apps sitting on your phone right now. Very soon, we're going to see AI autonomously discovering software vulnerabilities before hackers even get a chance. That means your banking apps become mathematically immune to glitches. In the crypto world, this means mathematically unhackable smart contracts and incredibly secure zero-knowledge proofs for your privacy. It's the exact same logic. The math that proves an Erdős problem is the same math that guarantees your digital life is flawlessly secure. And we're already seeing this exact thing happen in the real world. Just recently, Anthropic's Claude Mythos AI found over 10,000 critical software flaws in major infrastructure in a single month. In one crazy case, a bank actually used the AI to detect and autonomously block a fraudulent $1.5 million wire transfer dead in its tracks. So AI is rapidly shifting from just writing code to actively defending us. Now, historically, making software perfectly secure using formal verification was agonizingly slow. We're talking years of work by highly paid human experts. It cost a total fortune. But this new AI agentic loop, it changes the game entirely. It drops the cost of generating these high-assurance formal proofs down to just a couple $100. It's a real game changer. Which leaves us with this final thought. If an AI can solve a 56-year-old math puzzle for the price of a fancy dinner today, what everyday problem is it going to solve tomorrow? The barrier to perfect, hallucination-free logic has officially been broken. Thank you so much for joining me for this explainer, and definitely keep your eyes on this space. It is moving way faster than anyone predicted.